I guess we're in the last section. Today is what, 411? So we were doing some exponent rules. So I'll just combine these two into one lesson. We'll do the rules as we go. We'll put them up as I do them.
Okay, fine. Good.
They're called. Let's just say product. Let's say the exponent rules. I'm gonna call it two, it'll be 2.1, I think. Let me check it real quick. Move out of the way. What do we have here? 2 point, or so we'll do all of 2.1 today, parts A and B. All right, got it. Your test back.
Fast. Hurry.
If you have any questions, I'll be happy to take them.
Okay.
From the test?
Yeah.
All right, back in here, let me come back to our classroom's Blackboard site. And I just want to show you that if you go into here. Oh, the last question was screwy. I didn't do it before the test, so it came up really weird.
Yeah.
I'll give you the solution to it. Real quick. So I got the solutions in the test in here. When you do it, check this out. I gave you too small of a graph for them to meet. That thing way down there. But so I was good enough. If you just did this part and filled it out, I was happy. I don't know if I print them out or what I do with them. Yeah, I can find them. But I did a nice printout of it. It's somewhere way down like -32 and -25. What the heck? Interesting. Two numbers. I must have, oh, I gotta get rid of that. Okay. All right, perfect.
Oh, I see.
All right, the elimination one you said? Substitution, elimination.
You have an extra blank test that we just did.
Unfortunately, I do not. They are, of course, in the old test, if you want to print one out. In the old test section, in Blackboard, I put it there. And the solutions are there too. All right, let's take a look at these ones. let's grab the first one.
All right, gain here's elimination means we want to make one of the letters disappear and find the value of the other one. So if I first try to eliminate the x's, so let's work that in first. Let's eliminate the x's. So if we eliminate the x's, I'm gonna look at these things right here. I'm gonna try to make them the same, one negative and one positive. So what is the trick? What do I multiply up here by, down here by, to make it work out? No. Stop for a second for take this three here. Now pause, think about what you have here. Doesn't it start as negative 6x in the top, positive 6x in the bottom? Exactly what you want to accomplish. So this here turns into the following. We have negative 6x, 8y equals 24. And you also want to slow down. You want to go so fast that you're just doing things without thinking. I didn't do a -2 or a -3 anywhere because I realized that one of these was going to be negative, one of these was going to be positive. So the other one is going to be positive 6x minus 15y equals 21. Let me add these two things together. This is where the elimination happens. See these 6x disappear. What am I left with in terms of y? And what does that equal? 45. So divided by -7. But we get our y is, so when I put my answer, I don't know where I'm gonna put it, I'll put it up here, the answer. I have negative 45 over 7. That's wrong spot, that's why. There's the y part. Now I'll work the whole thing again to do the x part. So this time I'll eliminate y. This time, when you rewrite it again, I always rewrite it in the because I have negative 3x plus 4y equals 12. And I have 2x minus 5y equals 7. Now, the y's that I want to destroy. So what can I multiply each of the equations by to make it so you have a positive y and a negative y of the same amount? 5. You can use positive 4 and positive 5 because they already have different signs. So here, this time we're going to get negative 15x plus 20y equals 60. Then we have 8x minus 20y. This is where you know we've done the right thing. You're going to see that the y are going to disappear. And on the other side, you get 28. Add these. We get negative 7x equals 88. Then divide by -7. The x part of that answer up there was negative 88 over 7. Should I do the other one? Want me to do the second one too? All right, 7x, 9y, and 16. So plus 4y equals 5. I don't remember when I made it up. Yeah. All right, so I'll play the same games. I'm going to first eliminate the x's. Then I'm going to wipe this stuff out. So what can you multiply by to take out the x's? All you have to do in this one is multiply the bottom one by -7. And you'll have exactly what you want to wipe out the x's. Separate it from the previous effort. So I have from these two, the first one I'm doing 7x plus 9y equals 16, and the bottom one -7x minus 28y equals -35. What?
I probably,
Was 16 or 17? I don't remember. You do your best. Yep, it's 16. Well, I'll add these two together. It looks like I get negative 19y equals -19. Divided by -19. And we get y equals 1. The answer over here, I'll put it over here somewhere. I have 1 comma something. Then I'll go about eliminating y. I'll write these again. 7x plus 9y 16. X plus 4y equals 5. Now we're going to wipe out the y's. What can we multiply by each of these equations?
4 on the top, -9 on the bottom.
Right, you can be 4 in the top. And they have the same signs, one's got negative. So it'll be -9 in the bottom. I have negative, I don't know, 28x. Was 36y.
I did -36y. Oh, that's, I flipped it. Yeah, you're right.
Equals 64. The funny thing about this is, they're not hard to do, but people do confuse themselves. Especially when it comes to the signs and stuff. And the next one was -9x. Minus 36y, so that I get the y's correctly, they'll wipe out. I think it's -45. And these together, we get 19x equals 19. What is that for? 1. I put it in the wrong spot. Well, it worked out for me, didn't it? Why happened also the same value? Other questions on this?
So you saying this test we just did, you put it in there already?
Yep, it's already in the blackboard.
No, okay, it would be similar to that test you did. Okay, I was talking of, also.
Are you talking, wait, what are you talking about? I put the test you just took in the,
Mhm.
in, the old test. Is that what you're asking me?
Right,
Okay, yeah, put it in there.
but it's similar, it's not this exact test, correct?
What's the one?
Well, I'm gonna see, because well, look at all your right here.
Old tests?
Yeah, right here. Yeah, that's why I put it up. So that was test 3. And it said it's similar to that. Right.
See, that's the wrong date.
Oh, that's,
For spring 2024.
oh, okay. Thank you.
I'm confident about 75% of the time, so I make errors, but I'm usually right. Are there other questions? Well, today's stuff is completely different, though. We know graphing. It's going to be, we're going to deal with exponents and what do you know of exponents? So let me come down here. We're going to, in particular, we're going to be looking at section 2.1. That's where we develop all the basic rules of exponent.
This is, whoever wrote the book obviously doesn't agree with the order in which our school does it. They had it much earlier. It was called 2.1. Say it's exponent. And the whole game here is to try to develop the rules in regards to exponents. So let's first start with something simple. You recognize what that thing means. If you 2 to the 3rd power, what does it mean if I wrote it out in longhand?
2 times 2 times 2. 3 times.
2 times 2 times 2. Students, when they're really not desperate, when they're really flustered and everything, will tell me the answer to this is 6. 8. Okay. What about this one? Squared.
3 times 2.
It's fine. So none of this will be able to produce. You're familiar with them, that's all I care about right now. And we're going to build a bunch of rules based on this simple idea. So let's take a look. I want to do something like this. And a lot of these, I'm going to appeal to the most basic arithmetic you can imagine in the hopes that it will help you understand. So let's take a look at a rule that I'm trying to get across here. One of the rules looks like this. Suppose I do 2 to the 3rd power times 2 to the 5th power. Don't actually figure it out. And that's not what I'm trying to do right now. If I wrote it out in a long stretched out way, how many 2's would be here? 3. How many would be on that part? 5. The 8th power. How is that 8 related to the 2 and the 5? To 3 and the 5. How is the 8 related to those other exponents? That's exactly what we wanted to come up with. Do you see a connection? The 3, the 8 and the exponent versus the 3 and the 5 exponents. Do you see a connection between them?
So you can cross out the first 3, 2.
Not crossing out 8, no. That's not what we're trying to do here. I am trying to develop a rule that says if I take something to a power and the same thing to a power, what's the result?
Yeah.
That's exactly it. 3 plus 5 is equal to 8. You can do it right here. You've got 3 plus 5 more is 8. So the rule we're talking about here is if I have a number raised to a power and the same number raised to another power, I can add the exponents. All of these rules have names. I don't remember what they are. This is like the sum of power or something like that. But that's the rule that we're trying to get at. Any questions about that? So what I want to make sure that I do here is hit all of the rules that we're going to have.
Not that one. So this is, okay, it's called, well, you see, there's the name, it's called the product rule. Maybe I should do an example and then pull it up from here so that they have more words than I do. Ah, yes, I should do something like that.
So in this letter is not given to you. So if I were to give you something like x to the sixth power times x to the ninth power and ask you to write it more simply, what would you write it as?
X to the 15th power.
X to the 15th power. I hope you can see the 6 of them and then followed by 9 of them, you can feel that it's adding up. Question about that?
Power rule, okay.
So this was called, what was this thing called? Product rule. Okay, we can write it down. We have it. The only problem is that some of them have the same thing, but they're different rules. So there's a demonstration of that. So always keep in mind, everything we do, I'm going to give you a concrete example, and then we're going to try to generalize it to something like this. I also have to make examples where you calculate the things you need to do. So let's do 2 raised to the 3rd power, 2b 4th power. Now, according to the rules, what part are you supposed to do first? 2q, 2q. Do that. This is 8. I'm not quite, I don't want to do that. Really? I'll tell you what I want to do. Now what I'll do is, I'm going to take this block, do it 4 times. Well, there's only 3 of them. Yeah. In case you go longer. All right, so I have 1, 2, 3, I need 1 more. Now, the parentheses, when you're doing just one operation like multiplication, you don't need the parentheses. You just go from left to right. So if you allow me, that I write them up, how many there are total? How do you count total? 12. It's 2 equals 12. You see a connection between this answer and the exponents that were involved at the beginning.
Are they multiply?
Yeah, product rule. This one I think is called the power rule. So what I've demonstrated here is if you take a number and raise it to a power, and then raise it to another power, the answer can also be gotten by multiplying those exponents. I didn't mention the word exponent. You guys know what that is, right? It's a thing up there. Do you know what the bottom part is called? Like the A in that equation, but it's called base. It's called the base. The base to the exponent. So make note, this, in the last example, the bases have to be the same number. So you gotta be careful how you apply these things. So this rule is called the power rule. And so I can do something like x to the 9th to the 10th. Can you tell me what that would equal? X to what? 90. Take the product. X to the 9 times 10. X to the 90.
See this one? Look at the name of this one. It's a different rule, but the same name. Like, okay, that's why I don't like these. But I can't, nobody lets me come up with new names for them, so I'm stuck with it. All right, so let's go ahead and look at what they had. What I'm gonna do is a demonstration to show you how the rule comes about, and then I'll put up the rule. So this is what I'm looking at. I have two bases, A and B, whatever numbers those happen to be, and I'm gonna raise it to a power. But then I want A to that power times B to that power. So you see them all connected here, A to the.
So you get your,
Not really. I don't, but I don't see it where you're gonna get harmed if you do think of it that way. So probably I think it's okay. It's not distributed in the classic sense of being across an addition sign. But I don't think I see any problem with it. So anyways, what am I doing here? Oh, let me do a demonstration of this thing. So I need to keep, that doesn't actually matter, because we're not actually evaluating this stuff, I'm just using numbers to make it concrete. So let's see if I can mimic the example there. So let's do 2 times 3 raised to the 4th power. Now, I'm not going to actually evaluate it. I'm just going to manipulate stuff and move it around. Okay, so first, I'm not going to bother multiplying 2 times 3 out. Leave it. But I know that it's going to be 2 times 3, and I can write it 4 times. You agree with that? Now, since it's all multiplication, I can drop all the parentheses. Do you know why I can drop parentheses? Do you know what the rule is called that allows for that? Called the associative property. I use another property of multiplication, which means I can multiply in any order that I want. So I can rearrange everything. So I'm going to put all the 2's in the first, and I'll put all the 3's behind it. So the first, 4 2's. Then I'll have 4 3's. All right, now let's convert back to exponent notation. What did you write down? What's this guy gonna be? 2 or power. How about this one here? What's up? So as we were thinking about it, we distributed that exponent among numbers inside of the parentheses. So this is, we know it's called the second power rule. uh, 2.0. We have, if I have 2 different bases, but to the same power, then I can distribute the power to each number. So in particular, it's probably 2 to the fourth is 16, 3 to the fourth is 81. This would be easier to calculate than trying to do 6 to the fourth, I think. You know what I'm saying? These numbers are small and easy to work with. But 6 to the fourth, probably, because I had number 36 times 36, I don't know if that would be easier or worse. But anyways, so if I had A times C, 9, what would that equal?
A to the 9 times C to the 9.
That's right, B to the 9 times C to the 9.
Okay. Let's put that one. Oh, look at that, a third power rule. See it?
Power rule number 3. All right, this is, well, it actually, the name of it sometimes called the quotient rule, or quotient to a power rule. I honestly don't care what you call the thing. Obviously, B can't be 0 because you're not allowed to divide by 0. So let me use some concrete numbers for this thing. So the next thing I'm going to do, 2 divided by 3, and this time I'll raise that before number. And I'll do it the same way I've done all the other ones. I'm going to write 2/3 times itself 4 times. And then when you multiply out fractions, what do? Multiply the numerators. What do you get there? Not 16, 2 to the what? 4 to the 2 to the 4 over 3 to the 4. So the basic rule is if I have a number divided by another number, I take it to a power. And just got to make sure that B does not equal 0. That's important because it's in the denominator.
Questions? Okay. I bet you they use the same exact, oh, they've decided to put X down there. Well, that wouldn't bother with that part.
And then the fourth power.
Power rule for a quotient. Oh, okay, so it's got a more extended name. The power rule for a quotient. So there's a page with all your power rules. You want me to put them up? I'll put them up. I'll tell you what, let's put them up on this, in your notes. Terrible. If I can put them, there they are. Let's put them all up with an example and the rules themselves. Are you guys familiar with most of the properties that I've put up here, or is this new to you?
I mean, sorry.
Okay. Here, you obviously don't bother writing these down. You can look this up later when you look at my notes. This is also in your book, so it's not like you have to go hunting for it. We okay? So we had 4 basic rules. Okay, look, they all have names. Product, but no, basic power rule. Power rule for a product and power, so they do have different names. Now, as usual, then after the introductory stuff, we start doing things with them, which is what the second part of 2.1 is about. We're gonna combine the product and power rules of exponents. So I'm gonna pop down and I'll show you what I mean. I'm gonna do some examples and then obviously put you on them as well. So they just simply say simplify for all these problems, and that's what we're going to be doing probably for the rest of the class. Because all this is to get you comfortable with exponents. They are a pain to a lot of students, but once you get the hang of them, they're really nice and they're very helpful. So I'll just start stacking these up. I'll do one and then we'll go and work. I'll give you some to try. All right, they say simplify and they give you something like this. So what they're trying to do is I think they believe that you should just know what they mean by this. And really what they want you to get in the end is as simple an answer as you can imagine. So let's start. Let's look at the d to the fifth to the third power. Do you see a rule up here that is associated with this thing right here? Which one? Product rule. No, because they're separated in parentheses here. This has them inside of a parenthesis. What could I do with d to the fifth to the third power?
So basic power?
Basic power, well, you can take the product. Is that what you said? So when we do the basic power rule, I'll do the product. So I'll have d to the 15 times. And if you want, you can say, oh, I just used the basic power rule here for this, because I evaluated each piece. But now, what rule can I use for this one?
You add them together?
Just add them together. And what do you call that? That's the product. The product rule says that I can add them together. You have the basic power and then product. So that's going to be the nature of these problems. You're going to have to utilize those four rules to simplify the expression you're getting. Back.
How's that work?
Well, try to see if you can use the product rules or the power rules, which one of them is a bit, so you can work the left and the right using a basic power, using that, I mean, is it basic?
Is it like 3 squared plus r squared
3 squared times
times?
r squared.
So we write 3 times R to the third power is twice. And we do 8 times for the 6 R.
I'm not sure I understand what you're saying. On the first piece, you have two numbers, 3 times r, I don't know what r is, raised to a common power. So one rule says that I can write that part as 3 squared times r squared.
So if they be separately on this side, let's say. 3r, and I take it to the second power, the rule says that this equals 3 to the second times r to the second.
Okay.
The other one, I have to use this 2 and put it into the next one, and next one in each one of them. This is 6 squared, but this here, it's complicated. It's gotta be that big raised to the second power. Now, what would I use to work that last little piece there?
R to the 16?
R to the 16. So we've got 6 squared times r to the 16th power. That's one of those power rules.
And it's just,
So let me, well, yeah, let me underneath here, let me put what I've got so far. I got 3 squared r squared. This part was 6 squared r to the 16th. So I'll combine the r's and I'll put the numbers together. What's 3 squared?
9,
9
136, 6, which is 324,
Right, that's r squared times r to the 16th.
which is R to 80.
So when you get the 9 times 36, you can calculate your 224, 324 for that one. And how much exponent is on the r? 2 plus 16 is how much? 2 plus 16?
18. Okay, you got a 9 times. Oh, so you didn't put it in one, you just,
But is it 9 times 36 first? 9 times 36 equals.
okay, 6 times 6.
Oh, 6 squared is 36, yeah.
Yeah, but then that's wrong.
But yeah, evaluated at that point. I don't know, I don't think they care if we put the number as some sort of an exponent thing either, but this is probably what they're looking for in terms of the final answer.
Any questions about this? So as you can see, these things get complicated. So you wait till you see what the next one goes up, they're just gonna start going from there. So I'm gonna give you some to try. We'll do them one at a time. Let's start with this one first. Number 8. So you have to use all the rules on some of them, maybe multiple rules on any of them. Hmm?
How do you work out the negative P?
Treat the negative as like a -1, so that makes it a number you can work with.
Okay.
All right, anybody finish this one? Would you say?
So we write, we got negative nine, to the fourth power.
Just leave that alone. You didn't, there's nothing to do with that part. Now on the negative, I would, -1, exactly right. So you treat, right, to the fourth power. So each of those things in there will be taken to the fourth power. So what you're gonna see. I'll write under the C, we find all over everything then. First, nothing needed to be done there. That was pretty much. So P times Q to the fourth power. Then on this part here, what you're gonna have is you're gonna have -1 to the fourth. Then you're gonna have P to the fourth. To the fourth. But then Q to the fourth. Oh, you follow what I did on that second piece?
Yeah, I didn't do that. That's, it's not how it would turn out.
I don't know yet, we'll see. Yeah, I think it's gonna be negative, yeah, I think so. So let me go ahead and work all these parentheses. What do you get if you do -1 to the fourth power? What does that turn out to be? Not more.
It's just trying to,
It's just one.
yeah.
Anything, negative, when you take a negative number times itself, it's positive. Here, to the fourth is even more, you got -1, -1. And so any negative number from even power will become positive.
Okay.
So that's just one, I'm not even gonna bother with it. So I have my -5, I have P, I'm gonna put P to the one to represent that P. Q to the fourth, what's gonna be this, what am I gonna get for this piece?
P to the 16.
P to the 16. And then finally I have Q to the fourth. And like I do in all the other problems, we move things around, so that I'm gonna put the P's by each other and the Q's by each other. So this will be -5, P to the first power times P to the 16th power. Q to the fourth, Q to the fourth. So this is ultimately where you want to get to, because now the rules are just adding these exponents. So what's going to be exponent for P? 17. What's going to be the exponent for Q? P. That's right. We have -5. P to the 17 times Q to the 8. So you can see how vigorous these things can get. This isn't even nearly as hard as you'll be doing before we're done with this subject.
You ever see what a 19?
What 9?
And that's probably the same. Which one you got 9, you got a.
I don't know if I have, did I have a 9 in there? I had a Q.
Oh, that was a kid, oh.
I'll go ahead and try this. So this is the nature of the rest of the course, just working these things. They're gonna get worse and worse until the end of class. Now notice that all of the negative signs disappear. They're all raised to even powers and completely ignore the negatives.
What we're writing,
I'm sorry, what'd you say?
times negative.
Negative m squared times itself 6 times. Anytime you have an even exponent, the negatives will cancel out.
Oh, yeah, the I was thinking.
God will become negative, exactly. So you can ignore the negatives on both of these. So with that said, what is the first parenthesis going to be after you use the power rule? M to the 12th, that's right.
So we have for this part, m to the 12th power. Now, how about this part here?
That's a, said more than negative, that's,
6 is an even number.
no, you said the next one.
4 is an even number. What do you think the next part is going to be?
2 to the 4th
Times 2
times m to the 36.
2 to the 4th. If you want to do it in 2 steps, you could do like m to the 9th, then raise it to the 4th. Now, my last step, I'm going to borrow on my last step. I'm going to take the number and put it out front. That's just usually the way we write things. Do you know what 2 to the 4th is? 16. 16. I have 16. I'll bring down the m to the 12. This you said m to the 36. And then to finish it off, what do we do with the 12 and the 36? Okay. So I have 16 m to the 48.
Any questions about that? Maybe I want to see if I can, I may, bother that stuff. Okay, good, all right. I gotta use the time wisely, so I don't want to, get focused on one thing and not get through all that we need. So let's do.
So we just need to find Z to the third of it.
Say, I'm sorry, I didn't quite hear you.
What is that, find Z to the third?
What did you think it was?
So we just need to find Z to the third.
Well, yeah, they're not doing anything with that part of it,
So we don't do that.
but you'll combine at the end. This problem, like the previous one, has a negative that disappears,
So it's 16 Z.
squared.
you done with that? Let's go this part. Like I said, that negative goes away. What do you get here?
16.
Right, 16. What do you get for this part? Apply to each piece. Where? Now what are you gonna get for this? Or Z? 2 to this, right, you can get times 4. And then what about this part? How much Z? Let's do the exponent. Yeah, if you're gonna multiply that, if you're gonna take 2 times 3, it'll give you 6. Now, it's always been right before you're done with the problem, move things around so that these are all by each other, and we can find the exponents. So I'll put all the numbers in front. 5 times 16 times 4, and I'll put all the Z's next. You multiply those numbers all out, I believe you get 320. 5 times 16 times 4 is 320. And then what's going to be the exponent for Z?
11.
You're gonna add all those numbers up. I'll write it out if you want, so that you can go back to look at it. We added 3 plus 2 plus 6, that's correct. I'll finish it off in this next line here. 320, Z to the 11.
The one I'm worried about is the quotient.
Well, we're getting to those. I think there's the next one's up in the batter spots.
Any questions? All right. Yep, here we go. We have some fractions are beginning. Let's go ahead. And I'll do 24. I'll give it to you, but then I'll do it after you are done. Now remember, they also want you to simplify your answer. So if you can cancel things from the numerator and denominator, do so. Now look at the top of this, and what's going to happen to that negative on the top? No,
It's not even against those, is it?
it's not even this time. So what? It's going to stay. You're not going to destroy the negative. It's going to stay. The negative does not get destroyed here. The negative does not get destroyed here.
Is it there 9?
No. Negative 27. 3 to the third is 27.
Oh, I didn't want that one. So that part, 3 to the negative 3 to the third power is going to be negative 27. So let me write these down. We're going to have negative 1 raised to the third power, 3 raised to the third power, and then finally a to the 1 power. 12, a to the 12. Come down here. What's this going to be when you expand it out?
36 times b to the second.
Right. I'll do one more step than you did. Then 6 squared times b squared. And now I'll start fixing. This negative 1 to the third is going to stay negative. So we put that thing in, put it out front, I suppose. Does anybody know what 3 to the third is? 27. 8 to 12, and in the denominator, I've got 36. B squared. You see any simplifying that can happen? Right, you have 9 that was both into 27 and 36, doesn't it?
Yes.
Right, so you can't,
Well, then what about B and A?
so you can't do anything because they're not the same base. If they had the same, they were the same, like, they had 2
They're
8,
both A's, yeah.
right. But as it is, I'm stuck. Well, I can't do it one, that's all. So they're not like terms, that's. So 9 comes out of here, I get a 3 on the top and a 4 on the bottom.
Well, that's what I was confused, wouldn't that, doing it simplify the A and B as well?
Well, you can't until you know the numbers.
I know, that's why I was confused on how you can even do the 27 and 36. 12. So you, I don't understand how you simplify the one side but not, while the other one doesn't.
Well, if I knew what A and B were, I could,
Okay,
but since I don't know, I don't even know if they have common terms, do I?
yeah.
Common factors, do I? A, for example, could be 3, B could be 7.
So on a test, if you didn't simplify it to the lowest. you-
Yeah, whenever you have different numbers, different, we don't know that A and B are different. The thing is, since they're unknown, we can't do much with them until we know the numbers. Now, if they were both A's, I could work it. As a matter of fact, we will, the next class, we'll do that when we have, there'll be a quotient rule that we'll be able to do something with.
So maybe this will be an example. If A happened to be 3 and B happened to be 7, they wouldn't have anything in common. You wouldn't be able to cancel. So since we don't know, we can't say anymore. Does that make sense? You notice they're very careful. They're not mixing, they're not putting the same letter. Do you notice that? Because we haven't gotten to it. So they're being very careful in the problems they're asking you.
-5 to the 7 power.
To the what power?
7 power.
That 7 is not attached to -5,
To the 31.
right? One thing that you could do, instead of separating -1, like, I think that's kind of a pain. I just think of -5 raised to the power.
So on the top, I would have like -5, that thing raised to the third. And to the 7, that thing raised to the third. 5 squared and to the 12 squared. Anybody know what 5 to the third power is?
125?
100.5. So if there's -125. Okay, what's the M part gonna be?
And the 21st?
m to the 21st power. 25, on the bottom we have 25, n to the. Everybody else. What's gonna be that excellent down in? What'd you say?
So 25.
24.
And then 20.
2 times 12. Oh,
Oh, geez.
so in the future, when they're the same, we'll be able to do something. And so right now, since I do know these numbers, I can do something. You notice 25 goes in the vote. Heck, it's easy enough to know 5 to the third, you have 3 5s divided by 2 5s. You only have a 1 5 left over. So there'll be 1 down there, that'll be 5 up there. My final answer then, the negative, you can put it anywhere, I can put it out front. 5 and 1 first. Divided by n. So these problems, part of the determinations is to figure out when you've successfully completed the task.
I want to find the ugliest looking thing I can before we leave. How about 40? Does that look ugly enough? What looks worse, 36 or 40?
36.
All right, we'll take 36. Well, it's not going to be as bad because I can't do any canceling between 7 and 8, but 10 and 15. There's canceling that can happen.
That's true.
You could do pre-canceling. I'll do, do you still want to do that one though? 36?
Whatever.
Since it was requested. I think this will be a good enough chunk of them that you should be able to do the homework. So I'm going to do it, but I'm going to do it step by step here so you can see. Remember, according to the power, quotient, and all those rules, let's start with the negative. What's going to happen to the negative in this problem? It's going to go away because the whole thing is being raised to the second power. So what you do is you distribute that 2 to absolute everything inside of the x, everything inside of parentheses. I won't bother doing the negatives since we know it's not going to be there again. But what you're going to get is 7 to the 4th power. Put it again. All right, so 7 to the 2nd power. This chunk to the 2nd power. B to the 2nd. 8 to the 2nd. C to the 6th to the 2nd. Now you're going to use all those power inside of power rules. What's 7 squared equal to? 49, got it. What are you going to get with the 8 to the 4th to the 2nd? What will that end up being?
8, 10.
No, A.
Oh, you saw this.
I'm talking about some on the top. What is 8 to the 4th to the 2nd going to end up being equal to? 8 and 8. Take 2 times 4. Then B to the 2nd has nothing else to do, so hang here. Now, 8 squared is what? That one's 64. And then to finish it off, what's going to be, what's the C going to be? So C to the 12th, right? I feel like this is pretty straightforward. You'll see it goes off the deep end pretty quick. It's like, have you ever gone swimming in a place where it's like, they have a really shallow end, but then it's like,
Drop.
yeah. It's something like that.
All right, but that's all I have. I'm going to go ahead and close out here. Do you guys use these videos at all? If you don't, I won't bother with them, but if you do, keep making them.